All right, everybody. We have a request to do fall 2019 test 2, part 2, predict the products of these reactions. And we'll be sharing that screen right now. And maybe. Here we are. Okay. So the two reactions we've studied so far are adding a strong acid such as HCl or HBr to an alkene and adding water to an alkene with a catalyst, either sulfuric acid or toluene sulfonic acid, the one in this question. The results are always the same. You get an H on one carbon, and in this case, a halogen on the other. And in this one, you get an H on one carbon and an OH on another. The two obvious products are put the Cl here and the H here. That will be a minor product. How do I know? Well, this is an alkene on a carbon adjacent to a branched carbon, which means rearrangement will create the major products. So the straight up products will both be minor, and the minor one will have a Cl here, and the most minor one will have a Cl here. So here we go. We're going to put them here. The minor looks like this, and the Cl here. And the most minor will come from the secondary primary carbon, which has the least hyperconjugation. Oh, and that puts the Cl there. Now, to predict the products of rearrangements, it's very hard to do unless you draw the cation. So I strongly suggest, even though you do not get points for it, that you draw the carbocation. Please don't ask me to remind you after you get your test back that you will not get points for the carbocations. Here they are. Well, the one you need is here. It's down here outside the box for a reason. This is the one that can rearrange. We can have rearrangement number 1, where the methyl moves. Once again, you don't get points for the mechanism either. This is not a mechanism question. Or you can move the ethyl group. I am not going to do both of those at the same time. I'm going to do one and draw the product in red. If you move the methyl, you still have an ethyl on that carbon. You still have a methyl. Oh, that's terrible. You still have an ethyl and a methyl. The other methyl's gone. Where did it go? It moved over here, leaving behind a carbocation right here. That's where the Cl goes. So put the Cl there. Where you moved away from is where you're going to create a carbocation, right here. So the baby blue one will have the ethyl moving. So you'll have both methyls still. Both methyls still. And we go there, and where's the ethyl? It moved, it's here. Where's the carbocation? Well, before you put the Cl on, it's right here. Draw the carbocation there, you get no points. I keep saying it, it must be for a reason. I need the Cl there. These are final products, not intermediates. Okay, so that's the story there. On this one, I'm going to draw the two carbocations. I want to keep my molecule there. The two carbocations. Let's draw the two products that are obvious first. They'll both be minor. Both carbons are candidates for rearrangements. After you make a cation here, there's a branched carbon here. After you make a cation here, there's a branched carbon adjacent here. So that's why the box is so big. All right, so let's draw the two obvious products and put them up near the top. They won't be circled. because they're not major. And in the interest of saving a little time, I'm trying to save a little time. They both come from there. And we put a CL here for one of them and here for the other. Those are both minor. The cations that they came from. Cations they came from are these two cations. Plus here and a plus here. All right. The rearrangements in red and blue again. Hello? The rearrangements in red and blue are, you can move this bond. I'll draw that product in red. It's not the greatest arrow. If this was a mechanism, I might take a quarter point off. It's didn't really end at a carbon, didn't start at the bond. I can try to fix that, but I know it's not a mechanism. I'm not really grading it. That's different than moving the blue one here. I'll call that, I'm trying to call it 2. Oh boy. Move the bond. And I'll draw the result here. Red product on the just above it to the right. I like to copy everything except the bond I broke without moving anything because I have trouble visualizing things. So I'm going to draw every bond that did not move. There's the top of the molecule. This bond did not move. This bond did not move. Yes, I'm going outside the box. Let's see, the bond that did move is in black and it moved from here to there. And that's not the best looking bond. There. This leaves behind a cation on the carbon you moved away from. I hope you can see that. That's the carbon you're moving away from. That puts the cation here. What goes on it is an OH in this reaction. Please put the OH on it. And you're saying, wait, it's secondary. It's not a major product. And I'm saying, wait, this is not about hyperconjugation. This is about relieving torsional and angle strain. So this is a major product. I got rid of a cyclobutane. Forget about hyperconjugation. The blue arrow will also get rid of cyclobutane. The blue product, drawing everything except the bond I broke, is coming up here. I'll try to put it to the left here. We got this, the square starts, so start over. Square starts, square ends because I broke that bond. And then the next bond is over to here and down to here with ethyl sticking off of the next carbon, I hope. And we broke the bond from the dimethyl carbon to that and went to the adjacent carbon that goes from there to there. And the cation is now here. Yes, that's the carbon that lost a bond again, and that's its position here. Look, it's at the bottom of the square there, and that's where the OH goes. Also a major product. Why? We got rid of cyclobutane, torsional, and angle strain. Better do a save so we don't lose this valuable work. All right, the other product comes from the bottom carbocation here. I want to point out that if you move an ethyl group, you do not gain stability. You go from a secondary carbocation to another secondary. If the ethyl moves, this is down to 2 bonds to carbon. Don't move the ethyl group. You're going to move the H. H is going to move from here to next door. And we'll do it in hot pink. H goes there. And our product looks like this. Don't have to worry about cyclobutane changing. We got this, this, and this. And where's your cation now? It's down there on the carbon that used to have two, well, still has two ethyl groups. That's where you get an OH. Yes, it's an improvement in that you have a tertiary carbocation, and then it gets attacked by the water. But this is not going to be circled because it still suffers from torsional and angle strains. And that is the conclusion. There are five products here, two of them circled. And does anybody have questions about that? If not,
That was perfect, thank you. But do we have like, can we predict the number of products besides the two that we usually get from the original cations?
well, remember that if you're looking at the criteria for rearrangements, let's just use this cation here as an example. The bonds you're allowed to break create two products because you're allowed to break that one or that one. That'll give two more products. Now down here, rearranging ethyls didn't help, so it didn't give you a product, but you can always move an H if there is one, and that goes to a better one. So that only gave one more product. And the direct ones are the direct ones. And the short answer, I guess, to your question is no, there's not a formula you can use. But once again, in this course, if you don't get all the products, that does not sink your A. You might miss a point or two. Just do the best you can. And this blue arrow is really bothering me now. I can't let you go here. This arrow was wrong. I think if I stretch it out so that it goes to the cation. Yeah, there you go. It still looks terrible. But I had it ending at the carbon there, which is wrong. Yeah, that bond breaks and it ends up going from this carbon with the dimethyl to the next one down. That's what the blue arrow says, leaving a cation on this position here, which is where the OH goes. And I think that works. And we shall move on. I'm gonna end this and come back. We'll discuss a new video and then we'll take it from there.